Okay, folks, good afternoon. Good afternoon to everyone. My name is Marco Tamassia, AWS Principal Technical Instructor, and welcome. Welcome to this session, which is about data analytics on AWS. Before I start talking about technical stuff, let me set the context first. Let me give you some information about what you should expect from this session. And let me introduce also myself for a second. As I said, I'm an instructor, so I teach the AWS Cloud to people at the EMEA level, so Europe and Middle East. I'm based in Milano, north of Italy. And I'm also a former DBA, database administrator. I joined AWS 8 years ago as a DBA. And I got the chance to work on the databases that were part of our backend. So I got the chance to see our cloud from another perspective. And this session, by using AWS terminology, is a 200-level session. So it's an intermediate one. So in case there are some people here at the beginning of their cloud journey, it's not a problem. You're gonna get the most from this experience. You just need to know some foundational aspects about the AWS cloud. On the other side, if there are some experts in data analytics on AWS, you will find interesting this session anyway, because regardless of the information I'm going to give you about certain services, this session is useful because it allows you to get basically the state of the art of big data analytics on AWS. I'm gonna give you like the current trends and what are basically at high level the best practices that AWS provides to its customers when it comes to build the data analytics architecture on AWS, or when our customers want to move their current on-premises architecture to the AWS cloud. And this is a session organized by training and certification. I don't know if you know that. I'm a trainer, as I said, so what I always try to do is make these sessions, technical sessions, kind of training. So sometimes I will stop, I will give you some information or explanations about the core concepts, part of the data analytics world in general and also in the cloud. You will see that, you will notice that. And I'm going to start this session with a question: what do your customers want? This is an interesting question. If some of you or all of you have customers actually using your services or applications, and there are a bunch of possible answers there. You might think about yours. But I can show you what is basically the answer that our solutions architect have in mind every time they speak with AWS customers about building data analytics architecture in AWS. Customers want to understand them, listen to them, and proactively solve their problems. And this session is about the first part of that sentence: understand your customers. Because at the end, data analytics or big data, I'm going to use these two words as interchangeable. Data analytics is all about that. It's all about understanding your customer. Think about it. What we mean with the data analytics. We have basically a data analytics use case every time there is a company. This company has a business. And the business found somewhere some data, large data, big data, heterogeneous data, as interesting. And that data is just collected, ingested into a centralized area called data lake. More about it later. And then the data is cataloged, transformed, analyzed, maybe visualized. So you visualize the results of your analysis. To do what? What's the main goal? Again, understand your customers. So find answers to questions that the business have in order to provide value for the company. I can give you some examples. My favorite is the clickstream analysis use case. Have you ever heard about it? It's a typical data analytics use case because imagine you, the owner of a web portal or a website, and you want to understand your customers. What does it mean? It means that in that case, you want to understand what your visitors do when they visit your website. So what are the pages or the sections of your website they visit the most, the pages or sections that they don't care about, and where your visitors come from which websites, and which type of devices they use to visit your website, and so on. So once you have all of this information, and you get them by analyzing every single click that your visitors generate when they visit your website, you can find, again, answers that are important for you. You can find insights, useful information from that big data, in that case represented just by a large amount of clicks. Or think about the retail area, the retail business. If you are a retail company, you have your customers that purchase orders every day. They buy products every day. And understand your customers means what? Means understand what they like, what they buy, which products are sold the most, which products are not sold at all. You want to get information in order to organize your customers in clusters, maybe, in order to recommend to them the same things. Maybe you want to do some predictions about what customers will buy in the future. So data analytics is all about that, understand your customers. And on AWS, you can do that by building something like that. This is the idea that AWS has in terms of data analytics. It's called the modern data strategy. This is what AWS says. It defines this conceptual model. It's not an architectural diagram. It's more conceptual model where we have what? We have the data lake in the middle, the center of everything, and around the perimeter, we have all the technologies that might be part of your data analytics architecture with different roles. Sometimes they are actively part of your architecture. Sometimes they just represent the data sources. And here you can have a list, not exhaustive list, of AWS services that best represent those categories of technologies. In this session, I'm going to talk about those services, starting from the data lake and then covering the other technologies. But again, the type of the data analytics services AWS provides is much longer. The list is longer. And before talking about the data lake, let's stop for a minute and let's do some considerations together on this, on what you see, on this conceptual model called by AWS Lake House, if you ever heard this name. First of all, what you see is not just a technology, it's not just a service, it's not just a component, a resource. There are many. So AWS always recommends to build something, in this case in the data analytics space, with a combination of services, not just one. AWS doesn't like the one-size-fits-all approach. This is an architecture, if for a second we consider it a real architecture, this architecture is decoupled. Because we do every single thing with a different service, and because of that, we are able to decouple things. Having a decoupled architecture provides many, many advantages from the architectural standpoint. First of all, an architecture like this is more scalable because you can scale each single service independently. In an architecture like that, you can scale your data warehouse, leaving your data lake as is, or vice versa, for example. A decoupled architecture is also more high available. If one service or one technology goes down, the others are still up and running. And an architecture like this allows you to evolve easily it in the next future. So if one day you want to change your NoSQL database, in the future you want to change the search engine with another technology, another AWS service or a third-party one, you can do it, at least easily than when you deal with an architecture where all the components are tied to each other. Second consideration I want to do with you is, if you notice, maybe there are people expert on those services and you already noticed that, but all of the services in that picture have a serverless component, feature, deployment type. Did you notice that? So this is an important aspect. In my trainings, when I talk to my students, I always say the cloud is the perfect fit for big data. And one of the reasons is because of the fully managed and serverless aspect of our services, in particularly our data analytics services. Over the last 2-3 years, AWS made basically serverless all of our data analytics services. I don't know if you noticed that. So one of the main challenges that companies have when it comes to manage a data analytics architecture on premises is obviously the time spent, the effort spent on managing the architecture underneath, the physical architecture underneath. If you think about the technologies you see there, search engines, big data frameworks, data warehouses, all of that stuff usually leverages on large clusters made by large nodes, in the past running on commodity hardware, a mess. And now in the cloud, you have serverless services, a serverless data warehouse, a serverless search engine, serverless NoSQL databases, and so on. The third consideration I want to share with you is that these services are also very well interconnected, very well integrated. I will give you some examples for every single service I will mention in the next 35, 40 minutes. But the number of features that AWS released over the last 2 years is incredibly high. Maybe you heard about our zero ETL features, zero ETL integrations. But not only them, the streams capabilities that most of our database services now have. So the ability to move your data seamlessly around the perimeter or in different directions, like from your data lake to the outside or from outside to inside. And sometimes, I will mention some use cases and features. You can also query data. You can also process your data without moving it, in particular querying the data. I will give you some examples in a moment. So let's start from the central part of this lake house, of this conceptual model, the data lake. What is a data lake? The data lake is a centralized location where you store all of your historical data. It's the data that the business identified as interesting. It's the data that the business wants to use to get insights and the answers I mentioned before. In a data lake that is not a data warehouse, I will come back to this later, you have heterogeneous data. So highly structured data, the one that comes from your relational databases, but also semi-structured, I don't know, JSON files, for example, Apache Parquet files, or unstructured files, videos, audio files, images. We do data analytics on these files as well. And when you look at our data lake, again, it's not just a service. We don't have a data lake service. It's a combination of services that make your data lake on AWS an AWS data lake. We have S3, of course, that represents the storage layer of your data lake in the AWS cloud. Amazon S3, simple storage service, the service you can use for many use cases. S3 can be used for your backups. S3 can be used to store the static content of your web applications. S3 can be used to store entire static websites. S3 as a data lake, because it provides encryption in transit and at rest by design. virtually unlimited number of objects, virtually unlimited number of gigabytes you can store, storage classes that you can use to save cost based on the life cycle of your data. But again, S3 represents just the storage layer of your data lake. You need also other things. For example, a lake formation. In a data lake, you usually have many different IT roles that need to look at the data in there, and maybe they do that with different tools in different ways. So you need some governance on top of your data lake. And this can be implemented with AWS Lake Formation. Lake Formation is a serverless service that allows you to put in place this governance from a single pane of glass, from basically a dashboard, usually used by a new IT role, AWS, called the Data Lake Security Administrator. We imagine this service used most of the time about this type of people. And you specify who can do what within your data lake by creating lake formation policies that work on top of IAM policies. And you can implement fine-grained access control on your data lake and on your data catalog. The data catalog, when you have a data lake in the cloud or outside the cloud, you need a data catalog. My students sometimes ask me, many times I would say, but is a data catalog required? Technically not. It depends by the technologies you use for queries and for your processing. So if sometimes you process your data and the processing tool you use needs that the data is cataloged, you need a data catalog. And what is a data catalog? A data catalog is a database that contains metadata, data that describes the data in your data lake. Too much data. What do we mean with the metadata? So for example, if your data in your data lake is encrypted or not, and if yes, with which encryption encoding? If your data in your data lake is compressed, and if yes, with which compression encoding? If your data is partitioned, and if yes, what are the characteristics of these partitions? Or minimum, average, maximum file size? Or a record size? And this metadata is stored in a database, a separated database, historically a MySQL database. But now in AWS, you can use AWS Glue Data Catalog, which is a feature, a service that allows you to get a serverless regional catalog in the AWS region you need. You pay as you go for the amount of metadata you store. Why we need a data catalog? We need a data catalog because with that, we can basically provide a unified view of your data. Have you ever thought about it? Sometimes people work on stuff, but they forget to ask the why. You might have in your data lake Apache Parquet files, JSON files, CSV files, files stored in a database. But once you catalog everything, and you get a unified view of your data, a relational view, then your life is easier because you can just query your data. You can just run SQL queries. Everyone knows SQL. Everyone can learn it. And you will see that because of that, you can use services like Amazon Athena or technologies like Presto, Hive, Apache Spark. And with all of this stuff, you can easily query data, even if behind the scene it's completely different. I mentioned Amazon Athena. This is another serverless service provided by AWS that you can use to run Trino queries, in-memory queries against your data lake. It's serverless, so you don't need to put in place anything. You don't need to configure anything. Once you are authorized and authenticated, you can open the Athena dashboard and run your queries against your data. You just need a data catalog in place. And I already discussed most of the features, so you can see there most of the characteristics of of this data lake. And if we talk about benefits, I think among the ones you can see there, I would like to highlight the decoupled one. Even a data lake the data lake is decoupled, because we have S3 that represents, as I said, the storage layer. And then you can use whatever technology you want or you need to process your data. So if you want to do some machine learning stuff, you just get the data from S3, you train your model, you deploy your model, you can ask for inferences, and maybe the result of your processing can be just stored again in your data lake. The day you want to change your machine learning technology, or in general, your ETL technologies, you can do it. S3 will remain there, waiting for new files. Again, with the decoupled data lake, storage and compute can scale independently. And that's a very, very important benefit. And you know, S3 is a service that can talk to everything. It's very easy, develop a component, how can I say, a plugin for S3. Everyone can talk to S3. Is a web storage service, so wherever you are, if you are authorized and authenticated properly, you can just upload the data you need in there, or download the data you need. All of the AWS services are very well integrated with S3. Our services write into S3 logs maybe, or traces, or backups. So having S3 as the storage layer of your data lake provides you a lot of benefit in the AWS cloud. What about the databases, my favorite topic? AWS has more than 10 database services, more than 10. As a trainer, I teach a course. It's a 3-day course. It's called Planning and Designing Databases on AWS. And for 3 days, we talk about databases, only those database services. Why? Why so many? Because in the database world, we have now a lot of mature and popular database models. The distinction SQL, NoSQL is not strong anymore. When you say SQL, people might ask you, are you talking about a standard OLTP transactional database, or an OLAP analytical data warehouse? And when we talk about NoSQL databases, there are so many database models now, mature, that companies are using it. So you can see them, there are some of them, in-memory, ledger, key value pair, document-oriented, or graph databases. And AWS has a purpose-built database offering, and based on the database model you want to implement, there is a service that you can use. So let's focus on the relational model first. I don't know if you remember or if you know, sometimes I challenge my students when the relational model was invented, was, let's say, released for the first time in the 70s, 1969, and we are still using it. The relational model is very, very popular to use when, not always, but to use when you need the highest level of consistency when it comes to retrieve your data. A relational database always gives you the strongest level of consistency you can get when you read data. So strong that when a relational database cannot give you the latest version of your data, it gives you an error. And you use the relational database also when you want to perform ACID transactions, transactions that are atomic, consistent, isolated, and durable. In AWS, we have a service for that. It's called RDS, Amazon Relational Database Service, which is a fully managed database service. So it's a service you can use to build from scratch in the AWS cloud a relational database, or the service you can use to re-platform your unmanaged, this is the AWS terminology, your unmanaged database you have currently on-prem. RDS supports several engines. the enterprise Oracle, SQL Server, DB2, the open source MySQL, Postgres, and MariaDB, and Aurora MySQL and Aurora Postgres, which are basically AWS, MySQL, and Postgres compatible database solutions. I still remember when I used to be a DBA and I had the typical task, Marco, you need to create a new database. So I still remember the steps. I had to connect to the DB server and then configure the DB server to make the server a DB server, and then download the DB software, install it, and then I had to configure the software of the database, create the database, configure the database, and then implement the monitoring, backups, and maybe a replica. Manual tasks, even if there was a virtualization, still a lot of manual tasks. With RDS, you just connect it to the RDS dashboard, you click on Create Database Instance, you specify the engine, the edition maybe, the version, you specify if you want a replica or not, like with a yes, no radio button. You specify backup settings, encryption settings, monitoring, basic or advanced. Few other settings, then you click on Create, you wait 10 minutes, maybe 15, and you get a database that runs on a server managed by AWS, you don't see, if we forget RDS custom, and a database that is installed by AWS, patched by AWS, minor upgrades, we call them. And you just connect to the database, not to the DB server anymore. So the DBA experience changes a bit. But the idea is to focus more on the data, on the database schema, and all the objects in there, on the performances of your queries, rather than the, how can I say, the infrastructural aspects around it. And the benefits are many, and I would like to mention scalability and high availability. High availability because the multi-AZ feature RDS has, you just really change a parameter and you get a copy of your database in another data center at the end, in another availability zone. And you can scale your reads with the replica feature. So you can have read-only replicas. So asynchronous, in this case, a copy of your database opened in read-only. And RDS is very well integrated with our data lake. For example, every engine in RDS provides commands that allow you to easily export data from RDS to S3 or import data from S3 into your RDS tables, no matter which engine you use. And do not forget a feature of Amazon Athena, Athena Federated Queries, a very powerful feature that allows you to query data not only on S3, but also on any database or any data source you have in mind. Because if there is no an Athena Federated Query connector, you can build it with the related SDK. So you can query data that is stored in your RDS MySQL database and join that data with data on S3, for example, in your data lake. This is something possible. What about the NoSQL world? Let's spend a few words on one of the models, the key value one, which is very, very peculiar. And because of that, because of this model, the service I want to talk about is peculiar as well. Amazon DynamoDB, key value serverless database service that you can use to implement such a model. And why the key value is so peculiar? Because it's a model where it gives you its best when you work within certain conditions. With the key value model, so with the key value database in general, you usually need a simple database. In DynamoDB, even just one table. If you have more, we recommend you, if you want to create more than one, to not connect them. They need to be isolated. There is no join in DynamoDB. And your queries should be simple, key value pairs, key value lookups, and your transactions should be simple as well. So if you have a simple queries, simple transactions against a simple database, this is the moment where you get the most from a service like DynamoDB that can provide very, very huge numbers in terms of scalability, concurrency, and in general performances. Very, very low latency. DynamoDB is described by AWS as a single-digit millisecond service. But again, you need to work properly with that service because of the characteristics of the model. And when we can use DynamoDB or in general a key-value data model, I'm thinking about on a microservices application and a microservice website owned by a retailer, for example, the shopping cart service could be good if running on DynamoDB. You can implement a shopping cart with the DynamoDB table. Or a product catalog. Think about the gaming business, the leaderboard of a game, or a user profile table, the typical table you use to store a user profile's data. DynamoDB is very good also for that use case. In very popular video streaming platform, a video platform, movie platform, the product catalog is very often implemented with the key-value data model. So the list of movies you just scroll up and down, right and left, can be easily implemented with DynamoDB. The wish list in such application can be implemented in DynamoDB. All of these use cases basically just need a very simple table, isolated table, where you perform simple operations, in particular simple queries and simple transactions. Another thing, developers need to know in advance which type of operations you're going to run. This is another requirement with DynamoDB. Then you can get the most from this service. DynamoDB provides a virtual unlimited space with its table, so you can store how many data you want. You just pay as you go. And you are charged for the compute capacity you consume when you read and write data. And there are multiple ways, 3, to configure basically how the DynamoDB compute capacity is managed. You can manage in multiple ways, read and write capacity units. Again, very, very peculiar service, serverless, the first database serverless in the market, but extremely, extremely powerful if used pretty well and if used in the right way and for the right use cases. Do not forget also security aspects like S3. It provides encryption in transit and at rest, always available by default, by design. Is DynamoDB integrated with the AWS data lake? Yes, of course. Over the last 2 years, I don't remember now exactly when, but we released 2 very important features for DynamoDB. Our customers were waiting for those features for a long time. DynamoDB S3 export and import. Now you can have data in DynamoDB and export the data in that table on S3, or vice versa. You can have data on S3 and import it into Dynamo without consuming a read or write capacity unit. So that's crazy. This was the problem in the past, because every time you read your table, you consume capacity. If you want if you perform a full table scan, this is going to be a complex, slow, and expensive operation. But with these 2 features, you can move data from S3 to DynamoDB and vice versa without consuming capacity. The data warehouse. As I said before, the data warehouse is different from a data lake. In fact, in our lakehouse architecture, in our modern data strategy, there are 2 different things. I insist a lot during my data analytics courses with my students in my trainings on this aspect. It's the data lake now where you store all of the historical data. It's not the data warehouse anymore. In the cloud, in the data warehouse, you store just your recent data. Now, we can discuss about what the business considers recent. It can be the last day, it can be the last week, the last month, the last year of data. But even if you have a year of data in Redshift, you might have the last 20 years on S3. In AWS, we provide all the technologies you need to build a standard, traditional data warehousing architecture. So when the architecture where you have data sources, in the past usually transactional, and then some ETL workflows through which you extract the data from those sources, you transform the data, and then you load the data into your data warehouse/data lake. But the problem of such architectures is that the data warehouse is too critical. It becomes a so critical asset that when it goes down, it's a problem. It's a problem for the company. A relational data warehouse is not meant to be huge. It's not meant to contain terabyte of data. A relational database doesn't scale so much, especially horizontally. And if you have all of your historical data in a relational database and this database goes down, or worse, you have to restore the data warehouse, maybe you are blocked for days. That's the reason we recommend you to store your historical data on S3 and only your recent data in the data warehouse. So the data warehouse in a modern data strategy, folks, it's more now an analysis tool than a storage tool. You will see in many architectures on AWS, the data warehouse under the analysis phase of a big data pipeline. So the data warehouse is just one of the many tools you can use to run your analysis. Do you want to analyze your data through SQL queries because you are familiar with the SQL language? That's fine. You take the data, once processed from your data lake, you put it into the data warehouse, you run queries, and maybe you visualize the result with a BI tool. But now, in the cloud, you can also use other tools to analyze your data. You can use a search engine, for example. You can use services like Athena, or open source technologies like Presto or Apache Spark and a few others. But if you want to build a data warehouse on AWS, then we have a specific database solution, a purpose-built data warehouse service. And this is Amazon Redshift. Certain vendors where the same technology you use to build a relational database, you use also for the data warehouse. Maybe you just configure the two in different ways, but you use the same technology. In AWS, no. You need a relational OLTP transactional database, RDS, Aurora. You need a data warehouse, Redshift. Redshift is a service that allows you to create data warehouses that have an architecture that basically is built, is designed for analytical workloads. Everything is, how can I say, it has only characteristics that are perfect for an analytical workload. I can tell you, if you use Redshift as a transactional database, you will get bad performances. Redshift, in fact, has an MPP architecture, multi-parallel processing architecture. So basically, queries are executed in parallel across multiple nodes, but the same query is executed against multiple different roles in a distributed way by using CPUs and memory of different nodes. Storage, column-based storage, compression at the column level, data distribution at the table level, the ability to sort data at the storage level. So Redshift has a lot of features that make it the best among the AWS services to implement a data warehouse, so to support an analytical workload. This is a very important point for Redshift. And the number of features is incredibly high. And I always say to my students, I always ask to my students, do you know why the Redshift team was so active over the last years, and we improved so much our data warehouse technology over the last years because Amazon is using it. Amazon is our first customer. And so when a workload like Amazon starts to use a service like this, you can imagine how much data we got. You can imagine the challenges that we had to solve, how many times we realized we need certain features and we develop them. So this is also a reason Redshift is so rich and full of features. There is a course that we deliver as a training and certification. It's called the Data Warehousing on AWS, 3 days only on Redshift. Very well integrated with S3 and the rest of the AWS ecosystem. Redshift has really a lot of features, as I said, just to mention some of them. Redshift Spectrum, you connect it to Redshift, and by using a Redshift SQL, you can run queries on S3. So you are a business user, and you are looking at data about, I don't know, the orders related to a specific product, and the orders you're looking at are related to January 2024. Suddenly, you need to look at the same data, same month, but related to the previous year, 2023. So 2 options. You can just go to your data lake and copy the data you need in the data warehouse, or you can use a Redshift Spectrum. You perform a join, maybe, with data locally stored, with data stored in your data lake. So you can query data without moving it, as I said before. The ability to copy data from S3 into Redshift with the copy command, to unload the data, so to move data from Redshift to S3 with the unload command, 2 very powerful commands. Redshift federated query, so a feature that allows you, once connected to Redshift, to query data on RDS or Aurora MySQL and Postgres. Redshift ML. It's a service, it's a feature that allows you basically with a simple command, the create model, to start a transparent process that basically put in place for you automatically a machine learning pipeline that train and deploy a machine learning model with Amazon SageMaker that you can use in Redshift for inferences and predictions. And the model is actually trained with data in Redshift. What about the popular big data framework you might use, you might know in the big data world, in the big data business? Apache Spark and Apache Hadoop. 2 popular frameworks, both open source, but in the past running on large clusters made by a lot of nodes with commodity hardware, cheap hardware, and a lot of effort spent in managing the infrastructure underneath. Now, with Amazon EMR, you get basically those two frameworks fully managed or serverless. And if you think about it for a second, that's crazy. There is a principle in the AWS cloud that says, that goes, use your compute resources as temporary resources. And you can do this with frameworks like Apache Hadoop or Apache Spark. In fact, we insist, one of our best practice with those 2 frameworks is to work with the temporary frameworks, temporary clusters. So you have all the tools you need to create a temporary EMR cluster containing Hadoop or Hadoop and Spark. You can submit automatically 1 or more ETL jobs that are processed one after the other. Data is processed, maybe read from S3, processed. The result of this processing are stored on S3. And then you can just destroy the cluster. You don't need it anymore. And you can automate this process And you can start a similar process 1 hour later or the day after. You don't need to keep such an expensive resource because at the end it's a cluster made by nodes running all the time. Now you can just work with the temporary clusters. Service that gives you the ability to deploy your Spark and Hadoop clusters in multiple ways. EMR on EC2, for example, so standard fully managed deployment type, but also EMR serverless. So now you have also the ability to get these clusters completely serverless. You don't even call them clusters. You just upload and configure your ETL job, and then you run it. And EMR just manages, starts clusters for you. It runs your code, and then it destroys the cluster. You don't even see that process. It's completely transparent. And EMR on EKS. So you can run your ETL jobs, but the cluster manager is Kubernetes. You have also this possibility. And as I said, the benefits are many. But first of all, the management. You don't need to manage the underneath infrastructure anymore. And again, with technologies like Hadoop and Spark, it's a very, very important benefit. So what about the integration with S3, with EMR and a data lake built on S3? Now, basically, S3 is the primary storage solution for EMR. EMR provides HDFS. Yes, it's still there. But at the very end, HDFS is a temporary storage. So if you want to store permanently your data, you need to leverage on S3. Again, you decouple the two things, so the storage and the processing layer. So you read with your clusters data from S3, you process it with all the tools you want available in Spark or Hadoop, and then once finished, the result of your processing is just stored on S3 again. When I talk about Redshift, I said Redshift should be now considered, the data warehouse should be now considered as an analytic tool, an analysis tool, one of many. In fact, if you want to perform your analysis, you can use a search engine like the one you can create with OpenSearch. Amazon OpenSearch is a fully managed and serverless service that gives you the technology, the open source technology, OpenSearch in your hands. OpenSearch is an open source project where AWS is the major contributor. And you probably, some of you know that it's a fork of the popular Elasticsearch. In fact, the service used to be called Amazon Elasticsearch in the past. And when you build, if you think about the search engine, Elasticsearch in the past, OpenSearch now, it runs on a cluster made by nodes. Data in there, it's stored in tables that we call indexes, but they are like tables. Data is partitioned across multiple nodes, and this stuff is available fully managed, or if you want, serverless. So again, these are the trends, as usual. And you can create such clusters in minutes, and you get an endpoint with which you connect to it, and you can run your searches with the related language. And OpenSearch comes with a visualization tool as well, what we used to call Kibana, that now it's called OpenSearch Dashboard. And in terms of integrations, let's talk about the integrations. OpenSearch has, AWS released a lot of features that integrates OpenSearch with many services in AWS. There are zero ETL integrations between DynamoDB and OpenSearch, between S3 and OpenSearch, DocumentDB and OpenSearch. So with that, I mean that if you have data stored by, I don't know, applications you might have in DynamoDB, the data from OpenSearch, if this integration is in place, is immediately visible. It can be immediately queried, searched. Same thing for S3. You have your ingestion tool that is storing data maybe near real time on S3 with very low latency and high throughput. and you connect it to Elasticsearch, and you see the data coming in. Zero ETL feature. What about machine learning? This is the last topic, the last element of our lake house. Again, you might want to perform machine learning stuff on AWS. We have machine learning services. In particularly in AWS, remember, folks, that you always have the ability to decide which level of control you want to have when it comes to build your machine learning pipeline. You can still go for an unmanaged scenario. So you just spin up a bunch of EC2 instances, and you install there your models, your frameworks, your interfaces. Or you can leverage on Amazon SageMaker, fully managed service that allows you to build a fully managed machine learning pipeline. Or you can just interact with our machine learning services. So in that case, you call the related API. Those services, like the ones you see there, but the list is not exhaustive, have their own machine learning model managed by AWS, trained by AWS. You just call an API, and you get, with the recognition, your image recognized, with comprehend your review or comment with the related sentiment analyzed, your text translated by Amazon Translate, and many others. But again, a different level of controls. If you go for serverless, you lose a bit of control, but you get an easier life because stuff is already there for you. Or you can build stuff with making your hands a bit more dirty. Again, folks, I mentioned Amazon SageMaker, and this is a very popular service. We're not going to talk too much about machine learning here, but of course is an important service that we need to mention. Many features, very well integrated with Amazon S3 and other services. It allows you to build from scratch an entire machine learning pipeline from the beginning to the end. So it allows you to connect and manage your data sources. It gives you notebooks and similar features that help you implementing your data cleansing, data transformation, and data exploration activities. It allows you, obviously, to train your machine learning model with whatever algorithm you want to use, provided by SageMaker, imported by you from the outside. And then you can obviously deploy your model and validate the model, test the model, and then finally deploy it in production in multiple ways, and based on the deployment type, get inferences in different ways. Okay, folks, so at the very end, let me go to the conclusion. This is a lakehouse. This is what AWS considers a modern data architecture, data analytics architecture, made by multiple services, a combination of services rather than just one. Serverless services, so you can focus on your data, on your ETL jobs, on your processing workflows, rather than spending too much time on the underneath infrastructure. Services are very well integrated because of their features, so you can move data in multiple directions seamlessly, or you can even query data without moving it. And when I say multiple directions, the data can be moved outside in. Outside in, I can give you an example. You have data stored in DynamoDB. Maybe you have an application that is storing data in DynamoDB, separated application, not related to your data analytics workflow, but the business identified the data in that NoSQL key value pair table interesting, so you just wanted to take that data and copy it into the data lake, outside in. And as I said, all of our services are very well integrated with S3. Inside out, So you have data on S3. You want to use that data to do some machine learning. You can just move it to SageMaker. Or you can copy your data into your data warehouse for your analysis. Or around the perimeter. DynamoDB and OpenSearch connected to each other through a zero ETL integration. Same thing between RDS and Redshift. And this is the end. So again, quick recap. Lakehouse, modern data strategy, modern data architecture, combination of services, decoupled architecture, serverless, with data can be moved in multiple directions seamlessly, or with the ability to query data without moving it. And folks, if you want to learn more, as I said, this session is organized and managed by training and certification. We have plenty of courses that we provide. These are courses that I teach, and me and my colleagues teach every day, virtually or in person. Building data lakes on AWS. We talk about for a day about S3, lake formation, Athena, and Glue. Or building batch. For a day, we talk about Amazon EMR. Building data analytics solution using Redshift, a one-day course about Redshift, but we have the 3 days one as well. Streaming course. We cover the Kinesis family and Amazon Managed Service for Apache Kafka. Planning and designing databases on AWS that I mentioned before. 3 days focused on all of our database services, and a course specific for data scientists that want to learn more and want to learn how to use Amazon SageMaker. So I'm gonna give you 10 minutes for questions, but let me just very, very quickly give you a few information, and then I will be yours. Please remember, folks, that this is not the only type of sessions. TNC, the department I worked for, is organizing at reInvent today and in the next days. We have boot camps, spotlight labs. We have self-paced labs where you can just go there and work with our labs at your own pace. And do not forget AWS Skill Builder, our digital online learning platform that you can use to learn the AWS cloud. You find more than 600 free courses, but also courses accessible through a subscription. Can be monthly, annual, can be per individual, can be per team. But in Skill Builder, you can also find many other resources, resources you can use to get certified. We are investing a lot on quizzes and exam readiness courses you can find on Skill Builder to get certified with our certifications. Or SimulLearn, our generative AI-powered solutions, and the DILs, the digital instructor courses. So Marco and my colleagues who recorded our courses, also the courses I mentioned before, in a studio, and you can watch 21 hours courses at your own pace with Marco and other colleagues in front of the camera. Do not forget, folks, that because you are part of this event, you got automatically a 50% discount voucher for any certification. There is just one requirement. You need to book the exam before end of January 2025. You just have to book the exam before that date. Otherwise, the voucher will expire. And thank you, folks. This is it. Thank you so much. And if there are some questions, I'm here.